Okay. Hello, everybody. Welcome to Forks, Fragmentation, and the Future of Android. Now, I realized after submitting this talk that such a lofty title may have conjured up some really grand expectations in some of you. And if that's the case for you, let me apologize in advance if there's no way that I can possibly meet them. But for the rest of you, then I'm going to try not to disappoint. Oh, too late. I already disappointed. Why are you not responding here? Okay. My name is Chuck, and I work at Mapzen. And Mapzen is an open source mapping lab. We're based out of the Samsung Accelerator office here in New York. So what does that mean, an open source mapping lab? Well, we build tools and services that help people create location-based and mapping applications for both web and mobile. We also partner with a number of different organizations and companies on open data initiatives, open geodata initiatives in particular. So I want to start out this talk with a few statistics here. And so this first slide here is kind of an overview of smartphone sales worldwide in 2014. And so what we can see is, and these units are in the thousands, so at the top of the graph you can see Android is just completely dominating. In 2014 there was over 1 billion Android devices shipped, coming in at just over 80% of the market share worldwide. You can see following up behind that is iOS with 15% market share at about 191 million devices, and then you have Windows and BlackBerry and other things filling in the rest of the chart. Now this next graph here is looking at similar stats, but only from the second quarter of 2014. And the interesting thing about this particular graph is that it separates out Android into two categories. It separates the Open Handset Alliance and AOSP, or the Android Open Source Project. And so here we're able to see in a little bit more detail the fact that there's a rather large chunk of the Android devices that were shipped in 2014 were not running the canonical Google version of Android. In fact, about 1 in 4 of the devices that were shipped were running some other variation of Android that isn't necessarily compatible with the Google ecosystem. And then one more chart here I want to take a look at is fast forward to the third and fourth quarter of 2014, and you can see that the share of AOSP shipments has gone up even further to where by the end of 2014 it's at about 40% of all Android devices shipped are running some variation of Android Open Source Project, not the Open Handset Alliance version. You can also see a big spike there in iOS, and well, that can be attributed to the iPhone 6 launching. And then everything else is staying pretty much where we saw it throughout the full year of 2014. And then the last thing I want to mention with regard to these shipment statistics is this came along with the same report where the previous slide statistics were published, and that is that for the first time in the fourth quarter of 2014, we saw Chinese and Indian vendors accounted for more than half of the global Android shipments. So these emerging markets aren't really necessarily emerging anymore. They've passed the US and Europe as being the place where the most devices are getting into the hands of users. And so that's an important thing to keep in mind as we move forward and start to look at the Android landscape from more of a global perspective. So next I want to talk a little bit about the Android Open Source Project itself, I'm sure which many of you are already familiar with. For me personally, it's one of the reasons I chose to get into Android development. At the time where mobile was kind of coming on, and I took a look at iOS, and then I took a look at Android that was up and coming, I said, oh, you know, the fact that this is open source in particular appealed to me as a developer, being able to open up the code and see what's going on, and also the extensibility of the platform and the idea that it was like really a community-driven effort. Here's a nice breakdown of what exactly the different pieces of the Android Open Source Project are. So at the top level, you have the application framework itself. Moving further down, you have different system services and hooks to connect to the different forms of media. Down below that, we have the hardware abstraction layer. And then finally, at the bottom, you have the Linux kernel. And so this is essentially what comprises AOSP. And just like any other open source project, it's freely open and available. They take contributions from anybody who's interested in getting involved, and you can then take that code and you can modify it and do your own thing. And indeed, a lot of individuals and companies are doing just that. So what exactly are we talking about when we're talking about a fork of the Android open source project? Well, fortunately, Fox News helped us out with that recently when they published their GitHub dictionary. If you look down there in kind of the second term they defined, forking is simply the term for code editing. So I hope that solves all your questions, and we'll wrap it up here and I'll take any questions at the end. All right, thank you. No, but seriously, in the context of Android, what are we talking about when we're talking about a fork? Well, we're talking about a modified operating system that is based on the Android open source project. Now, a question I get a lot is, well, what's the difference between a skin and a fork? Well, a skin is just a type of a fork. So you have the different UI treatments and themes that are applied by, whether it be Samsung or HTC or Motorola. They all have a certain degree of customization to the look and feel of Android that they ship on their devices. And this is what most people call a skin, which is more of a lighter touch, not as a heavier modification of the operating system. Normally when we're talking about a fork, we're talking about a greater degree of customization, a little bit beyond what you would normally get from some theming and some styling. And then finally, and this is an important point, a fork of the AOSP may or may not be compatible with Google mobile services. This includes the suite of Google apps as well as Google Play services. Yeah, question?
So when you showed the graph earlier, you had the OHA as part of the pie chart, and you had AOSP as part of the pie chart. So what would get classified as Open Handset Alliance, or what would get classified as AOSP there?
Right, so the question is about how do you classify Open Handset Alliance versus AOSP. In terms for Google, it's whether or not your version of the operating system passes the compatibility test suite. And we'll talk a little bit about that. I have a slide for the compatibility test suite.
So it has nothing to do with forks?
Well, it does. So yeah, your fork can be part of the Open Handset Alliance if it still passes the compatibility test suite. If it doesn't pass, then you're in AOSP territory, the way the analytics firms define it.
Okay.
Yes. Thank you. Okay, so here's just a quick snapshot. So we're talking about Android forks. Well, there are a whole heck of a lot of them out there. Here is kind of an overview of some of the more popular ones, and we're going to go into a little bit more into depth about some of these individual forks of Android. So the first one I'd like to talk about is CyanogenMod. Probably everybody here's heard of Cyanogen by now, right? Just about? Okay. So it's one of the most popular forks of Android. And it's been around for a while now. There's a strong community of developers, and basically what Cyanogen is, it's a very highly customized and highly optimized version of Android. But it's still pretty close to the original version of the open source project. And so it is compatible with Google mobile services, but the way they do it is they make that optional. At the time when you install Cyanogen, you can decide whether or not you want to install the suite of Google apps, or if you want to run just pure AOSP on your device. And then it allows you to do other things like customize some of the performance details of your device, modify the settings. It allows you to do things above and beyond what you would normally be able to do through system settings. Like you can even change the behavior of some of your on-screen keys. Like if you want the back button to clear all your notifications instead of going back. I don't know why you'd want to do that, but you could. You can actually set up custom behaviors for some of these system level features of the OS. The next fork I want to touch on is FireOS from Amazon, another popular fork of Android, most notably known because it does not support the Google ecosystem of apps and services. And so what you have with FireOS, which of course runs on the Kindle Fire and the Fire Phone line of devices, is you have a highly customized interface. And you also they have their own app store, which kind of is designed to be really focused on the content, like the different forms of media. There are other apps available as well, but it's kind of a slightly different look and feel than what you would normally come to expect from Android. Which brings us to Oxygen. So this is the operating system being developed by OnePlus. We see a picture on the right there of the OnePlus One. The OnePlus 2 was recently announced. I think they're doing that whole crazy invite system again that they did last year. So good luck getting one of those anytime soon. But what happened was so Oxygen is kind of an interesting story, and I don't know the entire backstory to it, but when the OnePlus One originally shipped, it shipped with CyanogenMod as the operating system. I don't know if it's directly due to their messy breakup between OnePlus and Cyanogen over like distribution rights in India, or whether this was already the plan from the beginning to develop their own operating system. But now the OnePlus 2 is going to be shipping with Oxygen as opposed to Cyanogen, which is their own homegrown fork of Android. As of right now, I have a OnePlus One and I flashed it on there to check it out. It's pretty close to stock Android, very, very similar to the experience you'd get on a Nexus device, but it will be interesting to see where this goes over time as it evolves. And it is compatible with Google Mobile Services. Silent Circle is an interesting one. So the Black Phone came out a year to a year and a half ago. And so Silent Circle has been making privacy and security software for Android for a long time now. And they finally took the next step and built their own device with their own version of Android from the ground up that's supposed to be 100% focused on privacy and security. Now, the original version, the original Black Phone was a complete departure from the Google ecosystem in that it did not support the Play Store and any of the Google apps. Although they did recently announce that for the Black Phone 2, which is coming this fall, there's going to be a partnership between Silent Circle and Android for Work, which was the kind of the enterprise-geared flavor of Android to try to get into the workplace. And so, again, it will be interesting to see where this one goes, another relatively new fork, and it seems like it's going to undergo some significant changes to add back in the Google apps where originally it launched without them. So Xiaomi is the most popular mobile OS in China. And so, as most of you are probably aware, Google services aren't available in China, and this isn't only in the Android context, this is across the board. And so what Xiaomi did is they built their own version of Android and their own hardware that runs without any Google services. They have their own app store called the Mi App Store. And they have their own look and feel to it, which they've taken a little bit of criticism for the similarities to iOS. But otherwise, it's really nice and it's really polished. It's been around for a while. Now, Xiaomi also has, I'll get to you in 1 second, also has an international version of their device, which does support the Google services that they distribute outside of China. So they kind of have these two parallel versions of it. Yeah, question?
Is this the same fork that's been around, I guess, in the ROM flattening days? Because I just know, I wasn't sure if it's the same MIUI that's always kind of been around, but it's always just been like a ROM that developers have kind of made and finished.
Yeah, so the question is about the origin of MIUI or MIUI or MyUI, which I'm still not 100% sure how to say it. Actually, I'm not losing track of your question, but I did some research to try to figure out exactly how you say this, and apparently there's no consensus, at least among XDA developer users. But as far as whether this ROM like predated the Chinese version of it or the version that they're shipping on their own hardware, I'm not entirely sure. But I know that you can run their version of it. You could still flash their ROM onto your device. Most likely, if you're outside of China, you would want to use the international version for that. I've used their App Store as well. You can install that independently. Although if you're also running Google Play, it becomes confusing because they use the same package. A lot of developers will use the same package name in both stores, but they might be on different version numbers. So if you install it from one, the other one tells you it's out of date, or if you install it here, that one tells, and so yeah, you run into headaches like that. So there's one more fork that I want to touch on, and this might be slightly controversial, but Google Play Services is not, technically speaking, a fork of Android. It's an additional layer of services and APIs that you can include in your applications. That said, it's been referred to as Google's fork of Android because it's taking AOSP, it goes above and beyond what is normally available on the framework and adds some additional functionality that isn't necessarily compatible on other versions of Android. So what is Google Play Services? Well, when it was originally announced at Google I/O in 2012, it was basically a limited set of APIs to interact with Google+, and it also had OAuth single sign-on available for your Google accounts, and that was it. Now it's grown to include things like maps, push notifications, payments, and the way that you would use this as a developer is there's a client-side library that you would include in your application. And then on a device that runs the Google Play Store, there's a separate APK that gets installed directly from the Play Store and is updated independently from the framework. And so here's a nice illustration of how that all fits together, and this comes from the developer documentation. You would have the client library inside your app. Then you can see there it talks to the Play Services APK, which is directly installed via the Play Store. And here's a not even complete list of the different features and APIs that Google Play Services has grown to include. Things like, so you have some things here that were originally distributed through their own independent library. For example, cloud messaging, Maps used to have their own files or library projects that were distributed that you could include in your application. There's also some things that were, when they were originally came out, they went right into Play Services, like Android Pay, for example. And then you also have this other category of things in here that there may have been a previous version of it in the Android framework, and maybe there still is, but there's like the next step of it, the next evolution of it has now been added to Play Services as opposed to the framework. A good example of that is location services. Back in the day, before we had Play Services, everybody for location would use the location manager, which exists in the framework, and you would talk directly to the network provider or the GPS provider and get your location updates that way. Well, eventually in Play Services, Google rolled out this new location manager, which is the, not a new location manager, a new provider, the fused location provider, which manages the different sources of location for you and then kind of ties them together and based on some priorities decides which one is best for your app at that given time. Now, for me as a developer, and for for developers worldwide, there are some really great advantages to using Google Play Services. You have powerful features, you have the newest APIs from Google, and then the fact that it receives its updates independent from the framework kind of broke that cycle where a new version of Android would come out, but they would be beholden to the carriers and the manufacturers to give an over-the-air update, and that would lead to not everybody, really most people, not being able to be on the latest version of the framework. And so the new APIs wouldn't be available. And so the fact that it's updated independently is a solution to that problem, and that's really great. However, I see there are a few disadvantages through going through this type of model as a developer. One is the fact that it's closed source. So going back to our discussion about the Android open source project in the beginning, the fact that Play Services is closed source, to me, stands in stark contrast to the original philosophy of the platform. And it also can create some headaches for developers in that you can't step through your code like you could with the open source framework components. Once it's calling into the system, you don't know exactly what it's doing. It makes it a little bit more difficult to debug at times. It also introduces some concerns about privacy and security because you can't see exactly what's actually being done with your data. When you're talking about sensitive data, like location, I think is some of the most sensitive data out there, you don't know how this is being reused and whether it's individually identifiable and what other services or backends it's being exposed to, like you would if it was an open source component. It also adds a rather large footprint to your app, both in terms of APK size and the number of methods that count against the DEX limit. This can be somewhat mitigated by ProGuard, but it's still a concern. And then finally, and maybe most importantly, is it's not available on all devices. So if you want to have an application that targets more than one version of Android, including those that may or may not support the Play Store, then you can't necessarily rely on Play Services being available there, and you have to come up with an alternate solution for those other environments. So getting back to the question about the compatibility test suite, this is how Google determines whether or not a particular device or a particular fork of Android is eligible for Google mobile services. And so it's an automated set of tests that is designed to determine if this device plays nice with the Google ecosystem. The requirements range from technical to stylistic. So, for example, a technical requirement would be the Play Store. If it crashes, then you know that's not going to get approved. But then the stylistic requirement would be like, for example, at the top of your home screen, the Google search bar has to be top and center. And so you don't have any leverage or any flexibility as a developer, as a ROM developer, to put that in a different location if you still want to support the Google ecosystem. It has to be top and center. And so there are some stylistic requirements as well. And then finally, it is a prerequisite to getting the suite of Google apps and the Play Store and Play Services and all those other things onto your version of Android. So I think we already touched on most of these other app stores, the Amazon App Store, the Me App Store, the Silent Store, which is the one that comes with Black Phone. Yeah, question?
Yeah, you mentioned licensing the Google ecosystem. What does Google charge for that, or is there a charge?
There's been some conflicting information about this. Technically, there is no charge for licensing the Google apps. But maybe there is sometimes a fee associated with the testing process. I'm not 100% on that, so I would have to do a little bit more research. But I think the stance is that it's free to use, but maybe there are some fees along the way in the process of getting there, is my best understanding at this point. Maybe somebody else can correct me. So the one app store here that I also wanted to call out is F-Droid. Since we're talking about open source, F-Droid is an app store that is specifically geared to free and open source projects. And essentially the way this works is if you've ever used like Travis or Circle CI, for example, you set up a number of steps for your build process. F-Droid has the same thing. So they actually build your application from source. And that's how they guarantee that all your dependencies are free and are open source, is they check where they're coming from, and you can't include any binary that they can't actually build on their system. And it's another nice way that if you want to be involved with open source projects, that you can kind of guarantee that that's what you're getting in the Android environment. So now I want to touch on fragmentation briefly. We heard a lot about fragmentation when Android first came out, and in the beginning this was mostly an issue with screen size, display density, and the version of the framework that you were running. Well, fortunately, due to some advances in the system and things like the support libraries and some more flexible layouts that we now have available, these things aren't as big of an issue as they used to be, and that's great. You know, the support libraries are fantastic, and they are also open source. I will note there. But what I'm going to propose today is that we're kind of embarking on this new era of fragmentation of a different nature, which is that of different versions of the Android operating system, proprietary services that may or may not work across those different environments, and also distributing your apps through different app stores. And so now as a developer, rather than worrying about, oh, how is this layout going to look on a smaller screen and on a tablet and whatnot, we have to worry more like, oh, are we going to have these APIs available when we decide to launch our app in China? And so I want to talk a little bit about a few development strategies that you could consider using to deal with some of this diversity that's coming out in the Android environment right now. The first strategy I want to talk about is leveraging the Gradle build system and the product flavors. If you were using Maven, you could do something similar with profiles, but since Gradle is the official build system, that's what we'll focus on here. And so one thing you could do is create a unique build type or a unique flavor in your Gradle build for each different fork and or app store that you're targeting. What you would do then at the code level is extract a common interface for any component that was only available in a certain ecosystem. And then you can selectively include your dependencies based on each flavor. And then so this whole approach is the idea of having a single project that then when you build, you produce multiple APKs for all the different environments that you're planning to deploy to, or the different stores. And so what would this look like? So here's just a snapshot of what your what the outline of your build.gradle file might be. So inside the Android closure, we're going to declare 2 product flavors here. Let's say you want to build an app that you can launch in both the Play Store and the Amazon App Store, and you're going to be using maps in your application. So we'll declare 2 flavors in our Gradle file, and in our build.gradle. And then further down, where you declare your dependencies, now we can declare dependencies for an individual flavor. So you have, rather than just saying compile, you have Google compile, which links this dependency only to that flavor for Play services, and then you have Amazon compile, which links this dependency only to your Amazon flavor. And now when you build your app, you'll have 2 different APKs, one that includes Play services, one that includes Amazon Maps. Then at the code level, what we would do is in our source main Java, which is where your source files usually reside, you have an interface for a map. And maybe it has some high-level methods on it, like build your map, and as well as setting a location with a lat and a long. And then what you would do is you would generate additional source directories for your different flavors, where you actually implement that interface, and then you can include the environment-specific dependencies inside of your implementation. So you have a Google map that implements the map interface, you also have an Amazon map, and those should live in their specific source directories so that they get included at build time. Okay, so the next strategy I want to talk about is kind of the inverse of the first one, whereas the original approach was to have a single project that produces multiple APKs. Well, we can flip that around and we can have a bunch of different projects that all produce a single APK. And you might say, oh, well, that's crazy, I don't want to manage all this duplication of effort. But there's a way to do this that if you actually pull out build your own library project, essentially, that has all the core logic of your application, then you can reuse that library in your different projects, and then only add on top of it the environment-specific dependencies and the environment-specific code, but leverage that core library in all of the apps. And so what you would do is you would have multiple applications that each include that core library as a dependency. And this is what that might look like. In our made-up example, you have your company, and then you build this your company-core library, and then each one of your applications, and then you would have a project. You would have a project to build a single APK for Google, one for Amazon, maybe one for the Me Store, and then you would actually include that library in all 3 of those and leverage your code reusability that way. And then the third strategy I want to touch on here is swapping out some of your proprietary dependencies for open source. Really, this gives you a lot more leverage and flexibility and can be combined with either of the previous 2 strategies. And so a lot of times it might be the knee-jerk reaction to use whatever is the officially sanctioned API or service to solve a given problem, but oftentimes there are alternatives out there that might give you a little bit more flexibility. For example, with Maps, rather than using Google Maps or Amazon Maps or anything else that's particular to an environment, you might use something like Mapbox, which is an open source project based on OpenStreetMap, similar to some of the stuff we work on at Mapzen. And then you can actually bundle that into your application, and then you're independent, you're freed from any ties to a particular environment. Wherever you deploy your app, your mapping library goes with it. You're not anticipating or needing it to be there. Similarly, for analytics or even push notifications, there's a project called Countly you could use. And then for location services, here's my one shameless plug for one of our projects at Mapzen. We actually built an open source version of the Fuse location provider that comes in Play services to do a lot of the similar deciding which location stream to use based on a given priority, managing the battery. So we built an open source version of that uses the same API as the Google Play version of the Fuse location provider, and that could be an alternative to including Play services if all you need is a location provider. And so in the example that we were just needing Play services to get Fuse location provider in our application, you could swap out that dependency for something like Lost. Okay, so getting to the third part of my title, which is the future. I know I promised something about this, and so I'm going to do my best to fulfill those promises. Now, the future could bring us all kinds of things, including Android cheetahs, but that's scary as hell, so I'd rather focus more on the mobile device side of things. Here's an interesting article I came across as I was doing my research for this talk, and this comes from, I don't know if you can see the date there, but it comes from 2011. And this is a prediction by one of the analytics companies that provided the stats we saw at the beginning. And they declared in 2011 that Android will be on almost half of smartphones by 2016. Well, here we are in 2015, and it's already way beyond that. We're at over 80%. And so any sort of prediction about the future and what can happen is, there's a lot of variance in making those sort of predictions. So rather than boldly declaring what's going to happen as we move forward with Android and these different versions of it, I'd rather address the future with a series of questions of things that I'm interested in and that I'm going to be paying attention to as the environment evolves, and maybe you will be too. So the first one is simply, will Android remain the dominant smartphone platform worldwide? It is right now, clearly, but who knows what is the next thing that might pose a challenge to it. Taking that one step further, will Google remain the dominant force behind Android, or will some of these other alternate versions of it become more and more popular to where we're getting back to sort of the open source roots of the operating system? And then finally, will it become easier or harder for developers to target all Android devices with their applications? And for me, I think one way that this would be possible would be to get more back to the open source philosophy of the framework, have more things in the Android framework as opposed to these different add-on APIs that you have, one for Google, one for Amazon, one for whoever else, and really kind of get back to the roots of where Android came from. So that about wraps it up for me. I have one more modest request of you guys. Thank you for your time. That is, I submitted this talk as a workshop, actually, to South by Southwest for 2016. And it just so happens the public voting process is happening right now. So if you have a few minutes and you think that this talk is worthy of a vote, please log into the panel picker. They do make you create an account, but I assure you it's a pretty painless process. And then just click on the thumbs up, and I would really appreciate that. And thanks again. So it looks like we have a few more minutes for questions, if there are any. Yeah?
What is your opinion on Cyanogen mod and some of their bold statements that CEO made about wanting to, rip Android out of the hands of Google, and then also kind of talking about having Microsoft buy them?
Yeah, so the Microsoft thing, I haven't been following super closely, so I'm not sure what the latest is on that. As far as the bold statements, I mean, it's good for grabbing headlines, right? Besides that, I think that a healthy competition of different versions of Android is a good thing overall. And I feel like the more different variations that pop up in some ways will actually force more to come back into the open, which I hope is the result of this. So from that perspective, I think it's a good thing. It is a little sensationalist, their approach, but I think the overall effect on the ecosystem, for me, hopefully is going to be a net good. Sorry, and I should be repeating these questions. So that was about Cyanogen's bold claims about ripping Android back from Google, and then also about Microsoft potentially acquiring them. Yes?
How's the black phone doing? It's sort of gray area. No one really forecasts it, but it seems like a real opportunity.
How are they doing? Well, I don't think the Black Phone 1 had great sales. It was more targeted at individuals. I think the first market they went after. So how's Black Phone doing is the question. They originally went after kind of high-profile celebrities and people who are worried about getting their phones hacked and things like that. That was their original target audience, and so kind of like a high-end premium type of device. I don't think they sold as many as they were hoping to going after that market, which I think has led to their change in strategy, which is this partnership with Android for Work and moving more into the enterprise sphere.
It seems like a huge opportunity because when you look at mobile security, there isn't it. I mean, big corporations buy iOS, and it's not really getting more secure, and the device management isn't that great. And if you really have something that should be protected, it shouldn't be on Android, iOS, or Windows Phone at this point in time. And it seems like there's a huge opportunity that's been missed to have a chain of trust. You know.
Yeah. So getting back to mobile security, I mean, I've talked to a few security experts about this, and their response is basically once the device is compromised, you're really in deep trouble. And so if anybody gets a hold of your phone, there's really no security that's going to 100% prevent them from getting some data off of it. As far as mobile security in general, yeah, I mean, there are some people who wish that that was a higher priority for Apple and Google, for example, and the other companies that are putting out the operating systems. We hear a lot about the latest UI updates and you know, the latest this and that animations and whatnot. But I actually, you know, I'll put in a recommendation here that if you get to go to any of Mark Murphy's talks or his Code Lab, this is one of his favorite topics. And he's much more well-versed on it than I am. But yeah, if you're particularly interested in the security aspect, it seems like the more you dig, the less happy you are. Any other questions? I think we got time for one more. Yes?
What's the deepest that the forks go? Do they go into the virtual machine, the kernel? Like, how deep do the changes go?
So the question is, how deep do the changes go? Do they go all the way down to the kernel level? And I would imagine they could. I can't say that for certain, but I mean, it's all there. It's all available. So you could definitely modify the kernel. And if there's anybody who has, I almost think that it seems like Silent Circle might have been the ones to do it. Maybe some of the other companies that have done this have gone there as well. But it seems like to get that deep level of security that they're going after, they might have actually went to the kernel level. Okay, one more, last question.
Well, I was going to say, in the modding community, there's many people who you know, modified the kernels and posted online, and you can actually flash your own kernels. So I know there's been a couple ROMs that have been like completely redone with a whole brand new kernel, OS, and everything. It allows like to get better performance if you want to like overclock to the max and stuff like that. So it has been done.
Okay.
Not to the, I guess, mass that someone like signing them on.
Yeah, so kernel modification has been more of a niche thing that you're on your own and install at your own risk type of thing, rather than being like, you know, distributed by one of these large companies that are doing this. Okay, so before we go, I want to say one more thing. If you are interested, I've got some Mapzen stickers and OpenStreetMap stickers and Null Island. If you don't know what Null Island is, come ask me afterwards. I'll explain it. And you can get those from come talk to my lovely assistant here. My daughter Annika is with me today, and she's got all the stickers, so she will hand them out to you. And thanks again for coming out. I'd be happy to chat about this later or connect with me on Twitter. Thanks.